Hello everybody. Today we are going to take another look at some other types of functions we can graph. One of those types of functions is called a piecewise function. Sometimes they're called composite functions. You're going to need your notes today as well as a calculator. Just some general definitions or vocabulary before we start. A piecewise function is actually a function that is made up of pieces of different functions, which are a result of their different domains or their x values. So basically, it's one equation or one function made up of many different parts, and the parts only come into play based on different x values we can use. Today, you're going to see this little notation here, f with little x's behind it. I know we've seen this before, and many of you have asked me, what is that? That's read like f of x. That's how we pronounce it, or that's how we say it. It's f of x, and it's just like a y. It's just like our normal y. It's just another name or another way to name the function. It means function with x in it. So you're going to see that again today. Just remember that that just means a y value. So write this example down. We're going to do 3 examples today, graphing piecewise functions. There's a little bit to know and a little bit that's involved in each of these, so please make sure you're listening carefully as well as writing, and always pause a video if you need a second clarification or you need a moment to process what's going on. So what you can see here is that this is what a piecewise function looks like. Here's our f of x again. Remember, that's just like a y. And this piecewise function is made up of 2 parts. The first part is this 1x minus 4, and it's telling me that I should use that part if my x value is less than 3. And the other parts to my piecewise function, or the other piece, is 2x plus 1. And I'm going to use this one if my x values are greater than or equal to 3. Now, the easiest way to go about graphing a piecewise function, or the way that I'd like us to try, is going back to using tables a little bit. We'll get into what it looks like without tables, but for the video part today, I just want to focus in on making tables. So because there's 2 parts to this piecewise function, there's 2 pieces, we're going to make 2 tables. As always, this will be the x, and then the second column will represent our y values. Now, in the situation we have x's and y's for both parts. There's 2 parts to this piecewise function. So for my first part, I'm going to put x, y, and since I'm only going to focus on graphing the first part, I'm going to actually write the whole equation I'm using here. This is the first line, 1x minus 4. And then my second table is going to have some x values, and we're going to use this part, the 2x plus 1, to generate his y values. So we have 2 parts to this piecewise function, and we need to think about making a table for each one separately. Now, if I go back to the one that I've underlined here in red, just this 1x minus 4, that tells me that I should use x values that are less than 3. So in my column right here, I want to place x values that are less than 3. The catch is, I actually want to place the number 3 in there as well. And then I want to focus my table on continuing where x's are less than 3. So I'm going to start with 3 and then get smaller, like 2, 1, 0, dot, 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 dot. You know, that table would continue to get smaller. Now at 3, since I didn't really want to include him, because I only want x values that are less than 3, but I want to get right up there next to that 3, I'm going to actually make a note to myself that just like when we graph inequalities on number lines, there's going to be some open dots and closed dots. The 3 is an open dot here because, see up in the little description, that's a less than symbol, not less than or greater, or less than or equal to, but just less than. So now that I've figured out what numbers go in my x column, I'm just going to simply plug those in right there where you see that x in his equation. So 1 times 3 minus 4 is negative 1. 1 times 2 minus 4 is 2 minus 4, negative 2. 1 times 1 is 1, minus 4 is negative 3, and 1 times 0 is 0, minus 4, negative 4, and so on. This would just keep going on as I could continue plugging in numbers. When we go to make a graph of this guy, now we would plot just this part. Remember what we said here in my first dot? He's going to be open. So at 3, negative 1 on your graph, you actually want to place an open dot. My board's a little off right now, so I'm going to try that one again. There we go. 3, -1. And then 2, -2 will place a dot. And then 1, -3 will place a dot. And then 0, -4 will place a dot. And then remember, this goes on and on forever in our table. So we would connect all those dots and make an arrow. That is just graphing the first part of our piecewise function. The second part comes from this other table over here. Now remember, that's for the second line down here. So now we're going to use the 2x plus 1 if our x values are greater than or equal to 3. So now in our column, we want 3 again, but we also want to include numbers that are greater than or equal to 3. So 3, 4, 5, 6, so on. Okay, dot, dot, dot. And remember now at the 3, this is actually going to be a closed dot because it's got greater than or equal to in his description. It's not just a greater than, it's a greater than or equal to. So now I'm going to place those numbers, the 3, 4, 5, and 6, into the equation where that x is to generate those y values. So 2 times 3 plus 1 makes 7, 2 times 4 plus 1 makes 9, 2 times 5 plus 1 makes 11, and so on. We can continue this going on forever. So now to graph the second part, we'll plot the dots, 3, 7, and that's a closed dot right there. 4, 9, closed dot, and I'm running out of room on my graph here. 5, 11, kind of eyeball it. Okay, you can see that this closed dot and it continued on and on forever in this direction. So we're going to go ahead and make an arrow there. This is your first example, piecewise functions. They do not necessarily have to connect. There will be open dots and closed dots. There will be sometimes there'll be arrows involved here going on forever. I kind of indicate where the arrows go based on those dot, dot, dots in the table that I'm making. So be thinking about that as we look at some more. Here's a second example for piecewise functions. Again, 2 parts, 2 tables. So the f of x thing is just like a y. So y equals, and we have again 2 parts. First part, this little guy, if my x values are less than 5. Second part, this little guy, if my x values are greater than or equal to 5. So we're going to set up our tables in this way. We're going to go ahead and start placing in those x values based on the descriptions. So for my first one, x values I'm going to choose are supposed to be less than 5. I'm going to place 5 in this table, but then make a note to myself that I want to place an open dot there. That's what we do when we sketch inequalities anyway. We place those open and closed dots. So 5, and then it says I'm supposed to have x values less than 5. So 5, 4, 3, 2, dot, dot, dot. Okay, and then we'll go ahead and write y. And then the equation that I'm going to use is the absolute value x minus 3 right there. That's the equation we'll use to generate the y's according to the first line there of my piecewise function. So if I just generate those, we'll take a look. I'm going to place that 5 in that x value there. Absolute value 5 minus 3 would give me a 2. Placing a 4 in would give me a 1. Placing a 3 in would give me a 0. Placing a 2 in would give me another 1. Be thinking about this. Absolute value graphs mean I'm going to make a V shape. So I should be able to see a V shape when I start to make this picture. So I'm going to place my open dot at 5, 2. Ooh, board's off still. 5, 2, open dot there. Then I'm going to place a dot at 4, 1, 3, 0, 2, 1. You can see this V starting to come about. Now connecting open dots, and remember it continues on and on after 2. So this arrow here would shoot up like this. That would be the absolute value part of our graph. There is not another arrow on the other side. Remember that open dot starts us off. That's the starting place in our table. So now I'm going to sketch this other one. X again, y. The equation we're going to use is y equals 1/2 x minus 2. And in this table, we're only going to place x values that are greater than or equal to 5. So we'll start with 5 again. 5 is going to be a closed dot for us because it's greater than or equal to 5. And we want to be bigger or greater than 5 according to the description. So 5, 6, 7, maybe 8, dot, 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 continuing forever. So the arrow is going to go on that end over there. So if we place 5 into our equation, 1/2 times 5 is 2.5, minus 2 leaves me with 0.5. If I place a 6 in for the x, 1/2 times 6 is 3, minus 2 is 1. If I place a 7, 1/2 times 7 is 3.5, minus 2 is 1.5. 1/2 times 8 is 4, minus 2 is a 2. So you can see this line starting to emerge here, and then we'll go ahead and sketch this part, 5.5, and that's a closed dot, 6, 1, 7, 1.5, 8, 2. Remember, this is my closed dot, and the arrow would go on and on forever that direction. Okay, that's 2 examples of piecewise. Again, it's easier if you go about graphing each side separately or each part separately using a table according to the description. Another type of piecewise function is something called a step function. This one's actually pretty interesting when you take a look at it. Go ahead and jot this one down. This one has 3 parts. And again, the descriptions of what is happening with those x values is really important. This is like a y, so y equals 3 pieces this time. Y is going to equal 3 for x values between 0 and 2. Y is going to equal 1 for x values between 2 and 4 there. And then y is going to equal 5 for this description of x values. So every table has to match this sort of description of x values with some open and closed dots like we were doing before. Okay, so once again, I'm going to set up these tables. So for the first one, I'm going to use black here, x, y. So in this table, my x values looks like they have to be between 0 and 2. 0, 1, 2. That's a pretty small amount there. And we want to pinpoint or remind ourselves where the open dots and closed dots are. According to the description, this at 0 is going to be an open dot based on the fact that this is only 0 is less than x, okay? And x is greater than or equal or less than or equal to 2. So at the 2, we're going to place a closed dot based on the symbol that's in that description. Okay, now it's time to write or compute our y values. If we look at what we have there, it's y equals just 3. Not 3x, not 3 plus x, but 3. That means each and every one of these is going to be a 3. So when we go to place this part of our piecewise function on our graph, we're going to find 0, 3, and place an open dot there. 1, 3 will be normal. 2, 3 will be normal and closed. And it doesn't go on and on forever because it gave us a finite amount. It was from 0 to 2. Not greater than 2, not less than 2, but just in that little window. So I'm going to connect all 3 of those dots with a little line right there. That is one piece of our piecewise function. Now let's go ahead and do it for the second one. The second one says I'm going to have x's and y's. My x's are going to be between 2 and 4. So 2, 3, 4. And again, making a note to ourselves that at 2, we're going to use an open dot. At 4, we're going to use a closed dot. And then what do the y values become? Well, look, it says y equals just 1. Not 1 times x, but just 1. So each of these becomes a 1. So when we place this on a graph, 2, 1 gets an open dot. 3, 1 gets a closed dot. 4, 1 gets a closed dot. And again, we'll connect all 3 of those. Now our last table will have x values between 4 and 6. And I'm going to make a note to myself that the 4 needs to be open, and the dot that I make using an x value of 6 needs to be closed. And then, again, y is going to just be 5 for each of those x values. So 4, 5, I'm going to place an open dot. 5, 5, I'm going to place a normal closed dot, and 6, 5, I'm going to place another closed dot. And since our table does not go on and on forever, it stops and starts. This is what a picture of a graph of a step function would look like. It kind of looks, or we can continue the trend, and it sort of looks a little bit like steps. That's why it's called a step function. So tomorrow when you come, we're going to practice working on some of these piecewise functions, making tables according to their descriptions, and knowing where we're going to place open dots, closed dots, as well as arrows. Thank you for taking good notes today, and I will see you tomorrow.